Good afternoon, and welcome to our conversation on the NFV ecosystem. Today we're talking to John Healy. He's the General Manager at the Software Defined Network Division in the Datacenter Group at Intel. John, welcome, and thanks for taking the time to talk to us.
Sure. Good to meet you, Monica. Good to spend time with you.
Okay, so we're talking about the growing NFV ecosystem, and it's a big one, and Intel is a big part in it and a strong proponent. Maybe we can start with you giving an introduction of how do you see the Intel's role in this evolution?
Sure. Yes, and it's a journey that started actually several years ago. As we worked with the networking industry on how they could best utilize many of the technologies we'd been developing for our data center, for our server product lines, as part of how they could build next generation network infrastructure, and particularly looking at how they could take advantage of the ability to consolidate the different processing workloads that exist in networking, from what we call application processing through to control, down to the packet, and ultimately the signal processing. 4 big workloads that occur inside in networking equipments. We worked with them on how they could consolidate those and really land them and support them on a single consistent architecture of a standard, from a standard architecture and standard platforms perspective. That journey began several years ago, but what it did do is it created a foundation of what I'd call standard computing for networking, on top of which, when you add capabilities like virtualization and many of the other IT-centric technologies that have evolved and matured in the data center, it creates a platform for function virtualization to occur as a consequence of having a standard compute platform on which to run those applications and network functions. And then as the service providers who were really concerned about how they could continue to economically build out capacity in line with demand, came together maybe 2 years ago or more now to understand how might we mobilize the industry of our vendor community to start to support us with a new form of network, a new form of platform. They understood and recognized what we'd been doing. And so since that time, we've been working as really a provider of technology innovation and the building blocks on which these next generations of networks can be built. And that's really the history of where we began our journey in terms of where NFV has gone up into today.
Yeah, and that's interesting because NFV and virtualization has been incredibly hot over the last 2 years, but obviously the work started way long ago in trying to make sure that you have a standard technology at the core of it. And that I think it's a key enabler because in order to move out of proprietary solutions, you need to have something that is solidly widely accepted by not only exists, but it's accepted by a wide range of partners. So
that's right.
And so in order to create this ecosystem, my understanding from what I hear from you is that you have to work much more closely with your partners. It's no longer Intel launches a product. You have to work with your partners closely. Is that?
Yeah, that's absolutely true. The desire from NFV and very well articulated by the service providers and contributors to their original white paper in 2012 was how do I reduce the cost of infrastructure acquisition, reduce the cost of infrastructure maintenance, there's such called OPEX, and then how do I introduce new services much more expeditiously at a lower cost point, but also significantly reduce the time to market and time to money from those new services. So to do that, you need to have a very large, growing, burgeoning ecosystem of fellow travelers and collaborators who are prepared to work consistently together to ensure that can be fulfilled and delivered, because you need the ubiquity of supply right at the beginning stage in terms of how a system and service is put together, a solution is put together. But you also need it at the other end such that you can create a range of new services by working with a growing developer community, and they need a standard platform to program to. So the applications that you want to deploy in the network, that you want to procure from a wide set of potential vendors, needs to be available and needs to be capable of interoperating and working together on a standard platform. So to that end, assuming that's the set of challenges and sort of opportunities that we're trying to address, we take a 4-step approach. Work with the creation of the standards, the open standards, and indeed many of the open source components that need to evolve to create that environment of technology that's easy to access, easy to procure, and easy to work with as a step number 1. And we have a lot of work we've been doing there in terms of exposure of technologies, capabilities, and ensuring that the evolution of those standards is one that maintains the openness and maintains the spirit of interoperability. But then the second phase is how we aggregate our assets and bring what we call reference architectures to market. As you said, not a product that Intel brings that tries to replace a networking device, but a set of platforms that take the advantages that have been and the capabilities that have been enabled in the open source and open standards communities, integrates them with the technologies we're investing in. And I spoke earlier about our work on consolidating those workloads and how we've made the platform more and more capable of supporting the type of workload or processing performance required in networking, and then delivered them to the industry as a set of references. That's the second stage. The third, though, and the one Monica, you mentioned, that is growing that ecosystem. And so we launched a program a year ago called Network Builders. We have nearly 90 members now. This is a community of ISVs, hardware vendors, OS vendors, all of whom are working with us on enabling the introduction, based on those platforms and those open source components, actual solutions, the different building blocks of a solution that can realize real deployment and real fulfillment. And within Network Builders, there are three tenets for the activities there that all of us prescribe to. And one is that it obviously has to be an SDN NFV-centric activity. That kind of just makes sense. It's entirely designed to further the progress of those technologies. But it also needs to be compliant to the open standards and open source components, and have a philosophy in terms of the workings between those partners of ensuring that we maintain that. And then the third, we want them to work with our technology so they can help us to improve and we can help them to improve based on a symbiotic relationship between how we bring our technology and we optimize and work with them. That's our third phase, and that's an ongoing work. It's something that we need to continue, all of us in the community need to continue to spend time on, because that's what will grow the capabilities for an industry in terms of supply and availability of multiple product. And then the last of these is our activities around working with the service providers themselves in bringing what were initially proof of concepts, if you like, research activities in their labs, through to full deployment in the market, full deployments within their networks, and helping them and their vendors, chosen vendors, to optimize the implementation and ensure we're addressing any challenges that occur along the way. And we've been really excited by some of the progress that's been made over the last several months with, service providers like Telefonica and vendors like Nokia, all bringing product to market that is based on those technologies and really starting to show the commercial reality of what can be achieved with NFV.
Yeah, and you mentioned optimization, and I think that this is an important issue, because you don't move you extract from hardware and you can use any hardware you want, but doesn't mean that it just works. You don't just need to move functions. You also need to optimize to a new platform, which is what the vendors used to do on their own proprietary platform. So there is still a need for optimization. And how is that working out?
Yeah, that's an interesting challenge. And it starts really right back with what I spoke about earlier in terms of optimizing the platform's basic capabilities to support the building blocks that become the function that you're trying to support. Give you an example. When we started down the journey of supporting packet processing natively on a CPU, on a CPU core, the performance was not where it needed to be relative to what could be achieved in a fixed functional piece of silicon supporting packet processing as a function. But what's happened generation to generation right up to today is significant improvement each time we work through our microarchitecture and move from one generation of CPU to the other, by making modifications within the microarchitecture and optimizing the software that we run on top of it, which we've been calling our data plane development kit. Acceleration libraries to ensure those algorithms that are required to support packet processing functions can really operate at their best. We've seen a performance improvement that gets us to a point where we can support 160 gigabits per second on a single core today of layer 3 forwarding, which is a kind of a standard metric used in the networking industry just to measure performance. Now, from a CPU perspective, that's a single core, which is that's 320 gigabits per second on a dual core, and it was still ample overhead for all of the other processing that might want to be done on that platform. That's an optimization effort in and of itself, right down in the silicon. Then in the software, things like virtual switching for VM to VM support. The open virtual switch, which exists as an open source effort within the industry, has good performance, but we brought it in-house and we optimized it with our data plane development kit. And we're seeing very close to 10 gigabits per second switching throughput from VM to VM. Again, getting to a point where you're approaching the real behaviors of what used to be fixed functional devices. I mean, so much so that Brocade Viata brought a virtual router to market, which is every bit as competitive as other routers that might exist, but it's a virtual machine. And the beauty of it is that you get that level of performance in a software-only environment. So much so that you can go to Amazon Web Services and select and build a network using Viata's vRouter because it sits there as an available resource. Behind that, it runs on standard servers because the optimization has occurred in the silicon and the software has been optimized to support it. Now, are we done in that journey? No, we're not, because as we now push further and further into the telco network, the expectations of carrier grade, high availability, and ruggedized services in a manner which they have experienced and been used to for decades, much more work needs to occur there. So as we continue to work with the NFV Forum, the ETSI NFV Forum, in bringing those use cases that they've defined to fruition, a lot of effort on our side and with many of our partners will be on the further and continued optimization of the components required and elements required around creating that more ruggedized, more carrier sort of grade capability within those functions. That's the challenge I think that NFV is facing now, is moving from all of the real good momentum that's been created in proving and showing capability to now full mass deployment within the network.
Yeah, and you're right, and it's a continuous journey. Now, in terms of like the type of maturity of the ecosystem, there are some. How does it relate to the functions that are being virtualized? So there are, as we progress, there are more and more functions that are ready to be virtualized. How do you see that? What are the functions that can be virtualized first?
That'll move first. Yeah, that's a great question, and we're asked that a lot. And it's a question I ask a lot of my counterparts in the service providers, particularly. It appears that those, firstly, that have a propensity to be virtualized, have a heavy software centricity to how they're implemented, are those that will move more quickly. We're seeing a lot of activity around virtual EPC, the Evolved Packet Core, in the mobile network, because it benefits greatly from taking virtualized software-based implementations of the different components that made up the packet core, the packet gateway, the serving gateway and such. They appear to move very well into software and then run well in an environment where they can cohabit on a single server. In fact, China Mobile demonstrated an Evolved Packet Core, virtual core at Mobile World Congress this year. And it was multi-vendor. It brought all the components of a mobile core together, and they were all running on standard servers. So virtual EPC has gained a lot of attention, a lot of momentum. The virtual CPE, interestingly, flipping the letters around for the customer premise equipment, is also gaining quite a bit of attention because of the value it creates in lowering the cost, the operating cost of managing that high-cost piece of the network. And Telefonica are pretty public about what they've been doing and the trials they're running in Brazil in the deployment of a virtual EPC, or virtual CPE, sorry, where they can bring that back onto the edge of the network. Many of the functions, like the IP stack, like the routing protocols and such, that would have sat on the piece of equipment in your premise and required either a technician to call or the customer to do a self-install. Now, bringing that functionality back onto the infrastructure as a software load is very attractive for them. So that's because it reduces a lot of cost of implementation. It allows them to do upgrades as a software effort, and it doesn't involve technicians traveling door to door and driving around in vans and trucks. Big cost saver, very, very attractive. So virtual CPE, I think, is also gaining quite a bit of attention. Then if I flip from telco world into the enterprise world, the security appliance, what we would have purchased as a firewall or as an intrusion protection system, they're virtualizing too. We're seeing more and more traditional vendors produce virtualized versions, software-based versions of those sort of functions and machines, and then make them deployable on standard computing architectures. And that's exciting because that allows for the network administrator to move that threat management capability much more diversely across the infrastructure, not route traffic necessarily back to specific appliances or just host them on the edge of the network, but have the ability to do traffic investigation and security policing in multiple locations, depending on where they want to make that function reside. So from my perspective, they're the three big ones. We've seen others in BRAS and CDN for content delivery networks as well, but I think the three that are moving most aggressively are EPC, CPE, interestingly, and the security appliances.
Now, what about orchestration? That seems to be an area which is crucial, and yet it's a little bit more in the development phase.
Yeah, it's more nascent in the sense of the maturity of the technology, for sure. Once you create an NFV-centric set of capabilities, you need some mechanisms by which you can make resource decisions around where a VM should be placed, where a function can be placed. You can do it in a number of ways, but this seems to be where the world of SDN, the kind of centralized control and management, and the world of NFV kind of start to collide. So we see things like development and evolution of OpenStack as an orchestration mechanism, allowing for the better placement management of resources across the infrastructure, dependent on what the demands of a particular service will be at any one time. So projects like Nova and then Neutron, which is the networking-centric one, have been evolving. We've been working very closely with that effort to make contributions that do a number of things, like the exposure of a platform's capabilities, so that orchestrator can better understand where it should place a resource and take advantage of what the platform's abilities are. If you treat all the platforms as being sort of undifferentiated, then you can never make that best placement decision as to whether you want specific low latency or the ability to have offloaded and higher accelerated support for security and whatever it happens to be, depending on what the service requires. So that enhanced platform awareness, as they're calling it, is an effort within Neutron to create that kind of framework. And then within it, you need all the plugins such that you can talk to different aspects of the platforms, so that when an orchestrator, when an administrator is using that orchestration mechanism to deploy a service, they can talk down through the APIs and make the right placement decisions across the network. So orchestration is a key component of how the NFV and indeed the associated SDN will come to full fruition in terms of deployment. It's still nascent. I think there is still a lot of hardening to occur, but there's a lot of effort going on in the industry to mobilize partners around how that can occur.
Yeah. Now let's shift the focus a bit, because it's a huge technology shift, but at the same time, it's difficult for operators to push through they need to see a good business case behind it. How do you get that to work out?
There are the initial sort of what I call the green shoots of the business case. I think there are three areas that we constantly see end users describe as being their biggest worry beads, or maybe what we might call impediments to deployment: lack of standardization and lack of a true business case, and then in the case of others, the lack of the technology's maturity. And at this stage, that's a very fair representation. That's why we're spending the efforts and the time that we are. The business case one is evolving. Telefonica have seen a lot of value in their own internal modeling, which they've shown some of publicly, as to how virtual CPE will significantly improve their cost base. Others are working very diligently on proving to themselves what the difference is in terms of their entire operating model, because it flows everywhere from the acquisition of the technology being at a expected lower set of price points because of the use of standardized platforms and standard merchant supply, but all the way through to spares holding, maintenance, even capacity planning. And then, of course, the associated energy, benefit in terms of lower consumption, because they get greater utility and greater utilization of the platform. When China Mobile did the CRAN, the Converged Radio Access Network, or Cloud Radio Access Network, as some call it, they saw up to between 30 and 50% reductions in cost by deploying centralized processing at the edge of the network and remoting the radio heads from that central processing function to the base stations, as opposed to running each base station with its own complement of local processing and such. That was a significant reduction, both in cost of acquisition, but actually in maintenance costs, because a lot of the saving was in the energy. Now, but the business cases are still evolving. There's more work to be done. And that will really happen as a consequence of the continued deployment of real, commercial services, and then measuring and monitoring and understanding what's been achieved and feeding that back in. One of the activities we want to try to permeate and promote through our network builders effort, through what is now becoming a service provider portal, in addition to all the vendors, is the collaboration around those learnings and the sharing of the experiences, so that rather than having each reinvent the wheel themselves, they gain better benefits and synergies from the experiences that they're all going through, because it's to their mutual benefits to sort of accelerate their ability to adopt and prove to themselves the business case that can be achieved.
Yeah. Now, another change. So there is technology, there's the business case, cultural is the third one. And so this is virtualization forces operators to operate the network in a different way. And that involves also the people that are running it. How do you see that changing?
I think one of the areas that they don't highlight, interestingly, as a kind of a worry bead, is the internal cultural dynamic, and yet I think that is going to be a very, very significant, not insurmountable, but significant issue to be resolved, because culturally they've grown infrastructurally, both in terms of their network, but also in terms of their organization around how their technologies and networks were built. So they've large swathes of programming technicians and management technicians and engineers who configure and maintain the network, program through the CLI, the command line interface, and are used to building and managing infrastructure in that manner. Shifting that to a more software-centric world is almost like moving them from telco into IT. It's very similar to running the world of IT. So there's a reskilling and a reorganization to occur, and that will come up, meet its own inertia. John Donovan, in his keynote at ONS earlier this year in California, said AT&T needs to re-engineer itself from the inside out to take a true advantage of what NFV and SDN offers. And I thought that was a pretty profound statement. In addition to what they're doing with their domain 2.0 in how they're remapping their vendor landscape, this was a commentary on how they internally need to restructure and reorganize themselves. And that'll have to happen really across all of the providers if they're going to take advantage of what this presents, because there are functions they don't need anymore. There are functions they do need that they didn't have. There's a whole concept of DevOps, or development operations and development, where they can start to program for themselves services and functions they want to run on their own infrastructure. That's a pretty new concept for them. For the large cloud service providers, that's been the norm. For the service providers in telco, it has not. But it's an opportunity for them through which they may be able to differentiate the kind of services that they offer.
Yeah, that's very interesting. Okay, well, in closing, can you tell us a little bit about what we should expect from Intel and from the industry over the next 5 years?
I think we're going to see, from an industry perspective, I think it's exciting. We're seeing the initial deployments, the commercial deployments, which are clearly the real proof of the pudding. We'll see more of those through 2015 as many of the efforts that have been underway, somewhat behind closed doors, some of them in the labs, for the last 18 months start to come to fruition. That'll be really exciting. I think we'll see that shift occur, and that'll continue out over the next number of years as the technology matures through experience and vendors collaborate more and when we bring solutions to market. From an Intel perspective, you'll see us continue on the 4 vectors I spoke to earlier. We'll continue to work with in bringing more and more enhancements to the open source, more and more enhancements to open standards, and doubling down and continuing to invest in our own technologies so we grow the roadmap of capabilities. As I talked earlier around how our performance had improved generation to generation, we'll continue on that vector. Our view is that we need to continue to build the best of breed building blocks on which these new technologies can be, and new network infrastructures can be built. So we'll continue in that vein. And then very excitingly, I'm expecting to see that the ecosystem and fellow traveler community really matures to one that presents a whole breadth of alternates for those who are building networks such that they can compose from all of those different vendors. I'll expect that we will see real proof from that effort out over the next number of years. So I think you said over the next 5 years' time, in 5 years' time, I think we'll be living in a world has become much more NFV, more virtualized than it is today. But we'll still have distance to travel before it's truly become the network of choice, or the network of the future. But we'll be well on that journey in 5 years.
Well, okay, John, thank you so much for sharing your insights with us today. And this conversation is part of a report on NFV and its ecosystem. It is available on our website at www.sensafiliconsulting.com. Thank you very much.